Hello guys, today we are going to discuss about a very interesting problem, that is the magic square. This problem is present on HackerRank, uh, forming a magic square. So initially we'll discuss that what is a magic square and how we can form it. So a magic square is a matrix which has unique elements in it, and in which sum of every row, every column, every diagonal. So if we consider 3 by 3 matrix, so it will have two diagonals, it will have 3 rows, 3 columns. The sum of all 3 rows, 3 columns and both diagonals is same. So if that is the case, then we say it is a magic square. So if we have a case of 1 by 1 matrix, so there is only one element, so we can say this is a magic square, but technically it's we can say it, but it's not a very great example. In case of a 2 by 2 matrix, so do we have any magic square in case of a 2 by 2 matrix? No, we don't have any magic square. So I'll go onto the page which I have created. So in case of a 2 by 2 magic square does not exist. Recall that number in each box of grid must be distinct. So if we have the 4 elements in a grid, if we place 1 2 3 4 here, so sum across this diagonal is 5, sum across this diagonal is 5, but sum across this row is 3 and this row is 7, so this is not a magic square. So 2 by 2 magic square doesn't exist. Now comes the question of 3 by 3 magic square. So 3 by 3 magic square means it's an array of 3 rows and 3 columns, that is total of 9 boxes, and we can have numbers from 1 to 9, and the sum of all rows, columns and diagonals is same. So this is one magic square. If we see here, sum of 6, 5 and 4 is 9 plus 6, 15. Sum of this row is also 15, sum of this diagonal is also 15, sum of this row, every column and every diagonal, this is 15. And the most important and most interesting point here is, in this 3 by 3 magic square, the center number will always be 5. And how? I'm just going to tell you how. So in case of a 3 by 3 matrix, grid will have 9 boxes which is filled with consecutive numbers 1 through 9. The value of entire square, that is complete square, is 45, because we will have 9 numbers and all will be distinct, so we have to add all the numbers and sum becomes 45. So now sum of 3 rows, that is either we take these 3 rows, their sum must be 45, then sum of each row. So if we say there is this one row is unknown, this one, every element in this each row is unknown, so sum of each row would be 15, right? Now this means that the sum of columns and the diagonal is also 15. So it means if we have sum of each row is 15, then sum of each column is also 15, because sum has to be equal. That's how it's magic square. And sum of diagonals is also equal. So now this is the case that row 1 is equal to row 2 equal to row 3, column 1 equal to column 2, column 3, both diagonals are equal. Now finding the middle element, let's consider it as x. So now x is included in row 2 and column 2, it's included in diagonal 2 and diagonal 1 as well. So now what I have added is row 2 plus column 2, diagonal 2 plus diagonal 1 is equal to 60, because we have earlier calculated that sum of any row, any column or any diagonal is 15. Now in this case, this is the most important line, the recall the sum of all numbers is 45. Okay, since x value has been used 4 times in sum, so if we see here this condition, let's suppose this is a middle element, so this middle element in this sum comes 4 times. It means that 60 is made by adding 3 more times the middle element and 45. So now if we solve this equation, x will be 5, so we get the middle element is 5. Now to find the other elements, you have to simply ensure that all rows and columns and diagonals, their sum is 15. So all elements are unique. So this is one magic square. Now the important point here is keeping 5 fixed in middle. If we rotate the numbers, these numbers on which I am pointing my arrow, either clockwise or either anti-clockwise, it will always produce a magic square. So if we see here, the first magic square, I have written something like this: 8 1 6 7 2 9 4 3 and 5 in middle. Next magic square, I have written something as 3. So let me just shift 8 and 8 by 2 positions up, 4 comes here, so it will be 4 3 8. So or either I can do this way, that I move to this position, then move to this position, this position, this and this and this, and finally this position. So all in all there will be 8 magic squares. Let me just calculate: 1 2 3 4 5 6 7 8, and all are created by the variation or rotation of elements, keeping the middle element same. So to solve this problem, so now the problem, so now we are clear with the concept of magic square. Now the problem says is, can we convert this this element, this array, into a magic square? So now see here, 5 and 5 both are same, 4 and 4 both are same, so we have to convert this input 3 by 3 matrix into a magic square, and we know in magic square all elements will be unique. So this is the logic here, that create a 2D matrix which contains all the magic squares, then incoming, so it's an incoming vector, that is 2 by 2. I have just converted into a 1D array. Then simply I have calculated the difference of each position on the incoming array and the magic square arrays. So whichever sum is least, that means the answer is that magic square. That it means the answer is those difference, because that magic square is nearest to the incoming array, and the difference, the least difference, we can just provide it an answer. So for example, the input is this array. I have already taken this magic square here. Now I have converted the incoming array into a linear array that is called A. I have just called it A because the incoming is a 2-dimensional vector. Now in this case, I'm just going through each element in this vector. I can just say it as a 8 element 1D vector, and I'm just calculating the difference. I'm just summing the difference, and whenever I'll find a least difference, that is on first I found the difference on I equal to 0, I found difference 17, I equal to 1, I found 31, I equal to 2, I found 29, on I equal to 5 I found the difference is 7. So when I subtract the incoming array from the 7th, this element here, this is not equal to 5, so this is equal to 5. On I equal to 5, I found that the diff is smallest, and I stored that diff, so it means that diff will be the answer, because I stored best is equal to diff. So now in this case, these are, I have just calculated some differences, and the least difference is 7, and that is the answer. So I think it's pretty simple, right? The concept of getting magic square is only difficult. After that, it's pretty simple. So now the complexity calculations, this solution only applies to 3 by 3 matrix. Complexity calculation, space complexity is O(n) square, time complexity is again O(n) square. Why space complexity is O(n) square? Because if we have a 9 element incoming array, I'm just taking it a 2-dimensional, that is 81 element array, so this becomes O(n) square. And the time complexity, the time complexity in this case is O(n) square, because I'm just creating a linear array here, and so this so this is O(n) square, and then again I'm just calculating the difference of each of element in this vector, so it will be n multiplied by n, so it becomes o n square plus o n square 2n square, but I've just written it as o n square. So this is the video. Thanks for watching. Have a good day.